we are basically graphing lines, but we're graphing lines that also involve shading. So we're going to shade either above or below the line, okay? So these are called linear inequalities. So a linear inequality is an inequality that looks kind of like y equals mx plus b, but instead of the equal sign, you have greater than, less than, greater than or equal to, or less than or equal to. Okay, so that's our signal that we are going to have some kind of shading. Tess, are you with me? All right, so to find where to shade an inequality, we plug in a point that's not on the line and see if the inequality is true. Usually that point is 0, 0, but we'll talk about what happens when 0, 0 is on the line. If it is true, then we shade everything on that side that includes that point. And then the boundary line is solid if you have, oops, I totally messed this up. I did it backwards. If you have greater than or equal to, or less than or equal to, and dotted if you have greater than or less than. All right, so let's do some examples. So if I have y is greater than x plus 5, okay, this is going to be a dotted line because I have just greater than, not equal to. Equal to means we fill in the line as well. Okay, so we're not going to have a filled in line. Okay, do you guys all remember how to graph y equals x plus 5? Yeah, what would we do?
We could put the 5 on there.
Yeah, we start at 5.
And then x over 1. So you
Up 1, right 1, up 1, right 1. Yep, so the slope is 1. Do you guys all see that? Caitlin, put it away. So we have a dotted line. So we start graphing this line, but instead of doing a nice, like a solid line like this, we don't do a solid line. Instead, we do a little, like, dotted, dashed line. Okay, so that means that the line is not included in our points. Well, all right, so now we need to decide where to shade. So we're going to shade either above the line or below the line. Ryan, how about you sit over here today? Sit right there. You can already tell this is going to be an issue. All right, get papers out, notes out. Yeah, get some notes out.
Scott, do you have another copy of the notes?
Yes. All right, so we need to decide if we're going to shade this line or not. So we're going to plug in a point. So we want to pick a point that's off the line. So like I said, usually we're going to pick 0, 0. So we're going to plug 0, 0 into the original inequality. So when I plug 0, 0 in, I plug in 0 for the x and 0 for the y, and I get 0 is greater than 5. Is 0 greater than 5?
No.
No, that is false, right? So that means that 0, 0, which is right here, is not part of our shaded set. Okay, it's not going to be part of the solution. So we don't shade towards 0, 0. Instead, we shade which side of the line? Above the line. Does that make sense? So we're going to shade the other side. So we're going to shade up here.
False means you shade above.
False means you shade wherever you do not shade that point that we checked. So we don't check, or we don't shade 0, 0. We shade the other side of the line. So like if 0, 0 had been here. I drew this totally wrong. So let's say 0, 0 is here, and it was false, then you'd shade this way, right? You'd shade away from it. All right, so the next one. So I have y is greater than or equal to 3/4 x plus 2. So I'm going to start at my y-intercept of 2, and my slope is going to be 3/4. So I go up 1, 2, 3, over 1, 2, 3, 4. This time I have a solid line. So I had a typo at the top. I mixed up my solid and my dotted on accident. Okay, so I have a solid line when I have greater than or equal to or less than or equal to. So I'm going to draw the line in.
Wait, so you put it up 2 and then over?
Up 3 over 4. So go up 1, 2, 3, over 1, 2, 3, 4. Remember graphing lines? Just like lines we did before. Oops. So we have our solid line, and now we just decide where to shade that line. So we pick any point that is not on the line. So we don't have to pick 0, 0, we can pick any point. But 0, 0 is usually the easiest. So 0, 0 is below the line, right? So if I try 0, 0 in my original, I get 0 is greater than or equal to 3/4 times 0 plus 2. In other words, 0 is greater than or equal to 2. Is 0 greater than or equal to 2?
No.
Right, that is false. So we shade away from 0, 0. So here's where 0, 0 is. It's below the line. So we don't shade 0, 0. We shade on the other side. So we're going to shade up here. And that's our solution set. So basically what it means when you have a solution set is any point that you pick in that shaded region, and in this case on the line too, will work in that inequality. It will make a true statement. okay? But if you try anything that's not in the shaded region or on the line, it's going to make that inequality false if you check it. So if I picked a line, or picked a point like, I don't know, 5, 0. If I pick that and I plug it into the original, it's not going to work, okay? All right, so next up. So I have y is less than -1/2 x plus 3. All right, so how do we graph it?
Start at 3.
Uh-huh.
Go down 1 and to the left 2.
Nope, to the right 2. We wanted to go downwards in the end, right? So we have a negative slope. And we have a dotted line. And we decide where we're going to shade. So we pick a point, 0, 0. We have 0 is less than 0 plus 3. So 0 is less than 3. That is true. 0 is less than 3. So we shade towards that point that we checked. We shade towards 0, 0, below. All right, so that's our answer. Make sense? Now, if you have it in the form y equals mx plus b, you actually don't even need to check a point. Okay, so let's look at those 3 examples we just did. The first one was y is greater than x plus 5, and we shaded above. The next one was y is greater than or equal to 3/4 x plus 2, and we shaded above. And this one was y was less than, we shaded below.
So if it goes to the points to the right, you shade above it.
Right, if it says greater than, we shade above. If it says less than, we shade below. Okay, so that was like that one. Do you guys understand what we're saying? However, that is only when you have like the y by itself, when it's like y equals mx plus b in that form, okay? And on this next one, do you guys see what's wrong with it? Number 4, we haven't like solved for y. We don't have y on the left side, okay? So you can do that. Just remember, like when we have inequalities, if you ever divide or multiply by a negative number, we flip the inequality sign, right? Do you guys remember that? When you divide or multiply by a negative, you flip the sign. Okay, so that's a little bit harder. So in these ones, I think the easiest way to do it is to use the intercept method because it's set up in that standard form. Yeah.
On this test on Friday,
Mm-hmm.
do we have some form of notes with us?
Nope. You got to know this. This is like one of the main topics in Algebra 1. You have to know how to graph lines. All right, so the next one. So I have 2x plus 3y is greater than or equal to -6. So let's talk about the boundary line. So the boundary line is if I had 2x plus 3y equals -6, right? I know how to find the x-intercept and the y-intercept for that. Do you guys remember doing this before? So remember, if we're finding an x-intercept, we're plugging in 0 for the y. So cover up the y with your finger. We have 2x is equal to -6. So what is x?
3.
Close.
-3.
It's -3, right? So we plug in 0 for the y and got -3 for x. We write -3, 0. And the y-intercept. So y-intercept, we plug in 0 for the x value, right? So cover that up. We get y equals -2, right? So we have 0 for x, -2 for y. These are 2 separate points. So some of you guys, even on your quiz, were writing those as a single point. Remember, I said a lot of people try to do that every year. So it's 2 separate points, -3, 0, and 0, -2. We know that we have a solid line because it was greater than or equal to. So the equal to fills in the line. Oops. So we draw that line in. And now we definitely have to pick a point. So pick a point that's off the line. Can we try 0, 0 again?
Yeah.
0, 0 works. So I have 0 plus 0 is greater than or equal to -6. So 0 is greater than or equal to -6. Is that true? Ah, be careful.
Yes.
Yeah, 0 is bigger than a negative number, right? Does it make sense? 0 is greater than -6. So that means we are going to shade towards the 0. So we're going to shade this way. All right, now this one, the x-intercept, y-intercept method for number 5 doesn't work.
No, 0 doesn't work. What number do you use?
If 0, 0 doesn't work, you pick any point that's not on the line. We'll do one like that. This actually is like that. All right, so if I do the x-intercept, y-intercept method, you guys see if I cover up the y, what is x?
Not 0.
2x equals 0? Yeah, it's 0. So if I cover up the x, I also get 0. That's a single point. You can't graph a line with only a single point. You need 2 points, right?
So subtract 2x over.
You can subtract the 2x over, right? So I'm going to have y is less than or equal to -2x. So I subtracted the 2x over to the right-hand side. Now I graph. So this is in the form y equals mx plus b. It's just our b value is 0, right?
So it started at 0.
And my slope is negative 2.
To the right 1.
Yep, so down 2, right 1, down 2, right 1. Keep going. It's a solid line because it had the equal sign. So it's like that. And then I have everything. How do we figure it out? In this case, I've solved for y, right? So if I have it in the form y equals mx plus b, I can say, oh, y is less than or equal to. So that means I shade below, right? But if you didn't know that, you pick any point that's not on the line. A little bit hard on this one. We don't want to do 0, 0, right? You could do 1, 1. That works. So if we do 1, 1, we have 1 is less than or equal to negative 2 times 1. So we're checking 1, 1. So I have 1 is less than or equal to negative 2. Is 1 smaller than negative 2?
No.
No, that's false.
So you shade everything below it.
So we shade away from that 1, 1. All right, so this one's a little bit hard. We got to solve for y. So I'm going to subtract the 4 over. So I have 2y is greater than negative 3x minus 4. Divide by 2, divide by 2. When I do that, I get y is greater than negative 3 over 2x, and then negative 4 divided by 2 is negative 2. So I divide by 2 everywhere.
Is that a y or a 4 negative 3?
That's a minus 4. All right, so this one has a y-intercept of negative 2. And your slope is negative 3 over 2. So we're going to be downwards in the end, right? So we go down 3, 1, 2, 3 over 2. You could also go up 3 over 2, however you want. It's a dotted line because it was just greater than. It's dotted, like that. And then we pick a point that's off the line. So in this case, 0, 0 is not on the line. If you weren't sure, if you're like, ooh, it looks a little close to 0, 0, you can always try something else, right? So if I try 0, 0, I get, you can check in the original or the final result. I usually check in the original. So I have 0 plus 4 is, sorry, I keep coughing. 0 plus 4 is greater than 0. So 4 is greater than 0, which is true. So we shade up here. And that's our final answer. Does this make sense? Pretty easy for the last section? Yeah, just still graphing lines. Okay, so how do we decide if it's dotted or solid? Colin?
Oh, whether it's equal to or just.
So if it's equal to, that includes the line. It's saying the line is shaded as well. So that's solid. If it's less than or greater than, then it's dotted. Okay, so remember I made a typo on that first page, so change that on the first slide. So change that if you guys did it. And then how do I know if it's in the form y equals mx plus b? How do I know if it's above or below? Yeah, Xavier.
It's a
Greater than means above, and then less than means below. Right, perfect. All right.